Greetings and hello everyone. Today we're going to be working on our third day of our notes. So we have our problem right here. We want to describe the translation in each function as it relates to the graph of the parent function. So our parent function here is f of x equals x. And it's already been graphed here, so we don't need to graph this out, but if we were to change it over, it'd be y equals x plus 0. Now we can focus totally on our new function. And our new function is g of x equals x minus 8. So this is coming from the formula x plus k. Since this is my formula and I'm looking here, it's not quite in the form that I need it to be. So I need to change this subtraction over to addition. And when I do that, that becomes a negative 8. So my k value for this problem is going to be negative 8, which means that from my parent function, I'm going to have a shift down. So my equation is y equals x plus negative 8. My b value in this problem is negative 8, and my m value for this problem is going to be my slope, and it's 1, so this is going to be 1 over 1. So if I look at my scale, each one of these is worth 2. So I'm going to put a point at 0, negative 8, because that's what my b value is. I'm going to rise 1, so I'm going to go in between it. I'm going to run 1, and I'm going to go right in the middle. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. So I got enough points here. I can make a line from here. And as we said, there is a shift down that is happening from my parent function. Let's take a look at the next example. So in the next example, I have g of x equals x plus 10 minus 1. So here I have a combo that's going on. So here I have a horizontal shift that is happening, and I also have a vertical shift that is happening. So this negative 1 is part of my vertical shift, and the 10 is part of my horizontal shift. So my parent function, as always, is f of x equals x. And here, for my g of x, I have g of x equals x plus 10 minus 1. So my equation for my horizontal shift comes from x minus h. And then my k would be a plus k on the end. So if I look here, I have the opposite of both of these. So I have a positive 10 here. So that means my h value is actually going to be a negative 10. Why is it a negative 10? Because if I had x minus negative 10, the double negatives right there would turn into x plus 10, which is what I have in my original problem. So my h value is negative 10. Now my k value, as I said, needs to be a plus, but it happens to be a minus. So since the k value happens to be a minus, then it's going to be k equals negative 1. So what's happening in this problem? Well, we're shifting to the left 10, and then we're coming up, or down 1. So shifting to the left 10, down 1. So let's go ahead and build our graph here. So y equals x. We combine these two together, we get plus 9. So if I graph this over here, come up to 9, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. So this would be my graph. Let's take a look at number 5. So describe the dilation in each of the functions as it relates to the parent function. So I have g of x equals 1/3 x. So since it's outside of the parentheses, this is going to be a vertical dilation. Our parent function is f of x equals x, and it's already been graphed, so we don't have to worry about graphing it. My new function is g of x equals 1/3 x. As we said, it's outside, so this is going to be a vertical dilation. Now we want to figure out what our a value is. Our a value is the number that's multiplying the x. So in this case, our a value would be 1/3. Looking back at our notes, when we have an a value that is between 0 and 1, this is a compression. So this is a vertical compression. So it's going to make the graph come down a little bit. So let's go ahead and let's plot this out. So I'm going to start off with y equals 1/3 x plus 0. So my m value for this is going to be 1/3, and my b value is going to be 0. So let's put a point at 0. Point at 0. Again, my scale is going by 2s, so I'm going to rise 1. I'm going to run 3. 1, 2, 3. Rise 1, 1, 3. 1, 2, 3. Connect these up. And there would be our graph. Let's take a look at number 7. So our parent function, as always, is f of x equals x. So in that case, this is going to be y equals x plus 0. It's already been graphed, so we don't have to worry about graphing it. Now let's take a look at our g of x. So again, we're multiplying on the outside. Since we're multiplying on the outside, this is going to be vertical. Now we want to figure out, okay, what is our a value? Well, the number that's multiplying the x is 1.5, so a equals 1.5. Now I'm going to see, well, what is 1.5? And when we compare it to a, 1.5 is greater than, 1.5, sorry, is greater than, oh yeah, greater than 1. So since it's greater than 1, then we know this is going to be a stretch. So I can change this over to a fraction as I do it. So y equals 1.5 is just 3 over 2 x plus 0. So my m value is going to be 3 over 2. My b value is going to be 0. So I'm going to put a point at 0. I'm going to rise 3, 1, 2, 3, run 2, 1, 2. Rise 3, 1, 2, 3, run 2, 1, 2. And there is my graph. So go through and work on the even problems that are connected to these odd problems that we've done so far.